Hi everyone. I'm going to work through this radical functions study guide. I'm going to work through the odd numbered problems, just kind of demonstrating how we can do these. And then I'll ask you guys to, work independently on your even number problems. I'm going to do this video in two parts. I'll start with the simplifying, and then in part two, you'll see solving equations. So let's jump in. On this first section, what they want us to do is to first rewrite this expression in radical form and then simplify. So it will happen where we'll have, two different answers in some cases. We want to rewrite in radical form, and for number one, that'll be the cubed root of x squared. Now in this case, because the index is larger than the exponent, we're done. This is our final simplified answer. Moving over to number three, here we can see we have a negative exponent. So the first thing we want to do is rewrite this using radicals. So we can rewrite this as, well, the negative creates a fraction. So we'll have 1 over the square root of 16 to the third power. That's not fully simplified. We know the square root of 16. So we want to take this a few steps further. We'll have 1 over 4, because that's the square root of 16, and that's cubed. And when we cube 4, we get 1 over 64. Now you can see that simplified. We have no exponents to deal with. Everything's been reduced as best it can, and no radicals that are unsimplified. Let's move on to number 5. So here they want us to rewrite this as a radical first. So we're going to take our index, our denominator. This will be a fourth root. And then everything inside, x to the eighth, y to the second, is being raised to the third power. If we like, we can also write this as the fourth root of x to the eighth y squared, all raised to the third power. Those are equivalent statements. Now, because we have radicals here, a radical with an exponent larger than the index, we know that we can simplify this. So one thing we can do is apply our exponent, that 3, to everybody inside. We can write this as the fourth root of x to the 12th, y to the 6th. And then we can keep going here. It feels strange, but sometimes it's advantageous to rewrite this back in exponential form. We'll have x to the 12 fourths, or x to the third power, and y to the 6 fourths, or y to the 3 halves. From there, we can simplify this all the way down to x cubed y. And because we have, a leftover, right, 3 halves, we also have the square root of y. One other way of thinking about that, right, y to the 3 halves is the same as y to the 1 1/2, or y times y to the 1/2, which you can see directly matches our work in our simplified form. On the next section, we are really going in the opposite direction. So we will be given radicals, and then we will rewrite with rational exponents, and then simplify where possible. So in this case, we're going to simply rewrite first. The 4 is our base. The 3, the exponent, is our numerator. And even though it's not written, our index here is a 2. That becomes our denominator. The way I see this is the square root of 4 cubed. We know that the square root of 4 is 2. So this is the same as 2 cubed, or 8. Moving over to number 9, here we have the 6th root of 100 to the third power. And again, we want to rewrite this in with a rational exponent. So our base will be 100, our exponent will be the numerator, and our index will be the denominator. Well, here's a case where that fraction is simplifiable. We can deal with that. We can rewrite this as 100 to the 1/2 power, which I think you guys have done a nice job recognizing that 1/2 means square root, and the square root of 100 is just regular old 10. Let's look at one more here, number 11. Here is a case where we want to we have multiple expressions, or multiple terms rather, inside the radical. So we're going to put parentheses around 5 to the 6th and x to the 5th. And as we saw above, a square root becomes an exponent of 1/2. Now, what we're going to do is, it's not really distribution, but we're going to apply this exponent to everybody inside. So it'll be, and when we apply exponents like that, we multiply them times one another. So 6 times 1/2 will leave us with 5 to the 3rd power, and x will be raised to the 5/2 power. Now, again, I want to just circle back. I think some people were connecting to this last week. 5/2 is the same as 2.5. Well, where that helps us is we can rewrite this as x times 2 times x to the 1/2, because if we were to add these exponents together, we'd get back to 2.5, which is the same as 5/2. This helps us simplify because x squared has no rational exponents, and x to the 1/2 is just the square root of x. So our fully simplified form here would be 5 to the 3rd power, or 125, times x squared times the square root of x. I know this is simplified. All my exponents are whole positive numbers, and my radicals contain no perfect squares, in this case with a square root. On the third section of these problems, we are going to use our exponent rules, right? Specifically our product, quotient, and power rules. And what those rules tell us that we can do is that we can add, subtract, and multiply exponents in certain situations. In this specific situation, we have a base of 3, and we are multiplying those two bases together. When we do that, we can add the exponents. So we can rewrite this as a single base 3 raised to the 5 plus 7 over 3 power. Now that's not super clean, so let's rewrite that. We know that 5 plus 7 is 12. And we can simplify that fraction. 12 over 3 is the same as 4. And 3 to the 4th power, we can figure that out. 3 to the 2nd is 9. To the 3rd is 27. And to the 4th is 81. Let's look at one more. This one's a bit intimidating, right? We have a exponent on a fraction, and the exponent's a 1/3. So we can do a few different things here. What I notice is that both of these numbers, 8 and 216, are perfect cubes. Because they're perfect cubes, we can simplify them directly by applying this exponent to every term inside. So really what we're left with is the cubed root of 8 times the cubed root of x to the 6th divided by the cubed root of 216. Well, all of those are going to simplify and our radicals will disappear. The cubed root of 8 is 2. The cubed root of x to the 6th, well, that's the same as x to the 6/3 or x squared. And the cubed root of 216 is 6, which we can simplify our fraction down to x squared over 3. So that's just a taste. Obviously, we didn't go through all of those. I'd ask you guys to do your best. If you're not sure, there's a key posted on Schoology as well, so you can always refer to that if you need some extra guidance.